continuous wrist mode, by the way. There you are.
Come up a little, yeah. There you go.
Hey. God. My goodness.
That was long enough to see just for that moment.
Yeah. Eric, I'm holding here.
We're at 10 on the IGT.
Yeah, I think a little further away from us. It's not quite in the flow there.
All right, how about that?
IGT's at 72 and growing.
Roger, I'm holding here.
Up to 99. 107. 120. 125.
I got 150 on mine.
Oh, wow.
Okay, should I pull it up a bit?
Yeah, a little bit up.
So your thermocouple still reading?
Yeah.
Roger.
IGT dropped to the 40s and dropping.
Yeah, you just got to do it like micro
Micro
because you move
movements.
like 3 inches there. That's
Yeah. It's not what you want.
No.
How about that one there, guys?
IGT's at 6.
Yeah, you can see how it's
You
out
can
of the
see it
flow there.
now.
Yeah.
Yeah. How about now?
I'm at 39 and growing.
Growing 72.
I'm gonna hold here. Looks like we're in the flow when the current comes to our favor.
Now you can see it a little better.
Yeah.
For the moment.
81, 88.
Mine's fluctuating from the 40s to 80s.
Roger.
I got 70 now. 86, 98, 105, 132,
Wow.
123.
Yours is more sensitive today.
Only when it wants to be. 88, 101.
I'm at 41.
98, 110, 119, 133, 119, 91.
86, 89, 90, and dropping.
132.
108, 114.
Let me know if it gets too hot, Eric, then I can make an adjustment up.
120.
That's right on the number.
103.
IGT's dropping into the 50s, 40s.
73, 80, 89, 95.
270, oh, lost connection on the IGT.
I got 88, 105, 114, 96. '93, 71, 71, 112, 94, 107, 112.
For those of you on Nautilus Live, Eric is reading out the temperature in Celsius measured at the tip of that blue wand.
104.
If
85.
if you're watching the zoomed-in Herc view, take the occasional look at satellite channel 2 or top right of the quad, where you can see a wonderful view from Argus of Hercules positioned at this vent.
92. 90. 106. 71. 5 seconds left. End sample. And flow counts 12297. Final volume is 16.41.
16.41, got it.
Flow rate was 2 liters per minute.
Got it.
Good job, guys. You had to work for that one.
Yeah, that was a fun one.
Yeah.
Let's move the probe up an inch. I want to see what kind of temperatures we get there.
Roger.
No.
All right, that's about an inch, I think.
Is it written here on this? Is it written on?
Erica, I got you up an inch there.
Thank you. Stand by.
Roger.
Just while we set up, let me give you guys on Nautilus Live an update. We're currently really up close to one of the hydrothermal vents that make up this Seacliff hydrothermal vent field. This is a region of hydrothermal vents that's part of the Gorda Ridge tectonic plate boundary where the Pacific and the Gorda plates meet each other. This whole feature is 180 kilometers off the west coast of North America. That's where the Nautilus is stationed at the moment. And Hercules and Argus are currently operating about 2.7 kilometers beneath the ship on the sea floor. Thanks to those of you on Nautilus Live who are offering IGT jokes. At the moment, we're using the super sampler, which stands for the suspended particle rosette. If you can get any jokes from that, I'll give them the best shot.
It's the best IGT one that you see so far.
Oh, no, it's, oh, actually, well, the only one I've got so far is, who is an IGT's favorite president?
I don't know.
ISO Barack Obama. You asked.
It's true we did.
This is why there's only one of us who's exposed to the Nautilus Live question and comment feed.
True.
That's the appropriate response, I think, for that joke. A groan.
Oh yeah.
Yeah.
No, that's a
It's a
good
groaner.
that's a good measure of success for a bad joke on
Yeah.
Nautilus Live.
All right, I'm gonna sample here.
All right, I just repositioned you a little bit so that you're not against the rock. So let me know if the temperature changes.
I'm getting between 50 and 60 degrees right now.
And what's your goal for this one?
Around 50, 60.
Okay.
IGT still isn't communicating.
Do you want us to cycle power up here for the IGT?
Eric?
Yes, I could cycle it. I'm getting pretty low temperatures, 35 degrees.
Yeah, I think the fluid flow went away from you.
Okay, cycle power to the IGT wand.
Okay, IGT's back on.
Eric, what temperature are you eating out there?
35, 30. I'm gonna need to move closer.
Okay, but we saw 50, 60 before?
Yeah.
Okay.
$19, $15, $14.
So it's a bit further away from us then. Looks like we're in the flow here.
50 degrees, 66, 73. That's good right there.
Yeah, I'm frozen here.
Sampling now.
Roger.
Wheel is spinning.
IGT's dropping.
I've got 71, 73.
IGT's at 11. 10.
$72. How are we on time, Nicole? $90 degrees.
IGT's at 7.
Yeah, I mean, so we're about half hour behind in time, but that's not terrible. Do you know, Eric, how many you'd like to do?
Probably gonna. Are we gonna visit any more high temperature sites after this?
Let's see.
I remember is this one. This was the 270 one that they're talking about, right?
Yeah, this is, I think, the only one. After this, we're collecting a rock, deploying a marker, picking up the incubators, and then doing some mapping survey before we conduct the geotransect. So yeah, this would be our your chance to get these samples in today.
Okay.
So for those of you following on Nautilus Live, you can hear the scientists talking back and forth in the control van. At the moment we are measuring the temperature of this vent fluid as we sample it. So those numbers that you can hear being read out occasionally, those are the temperatures of the vent fluid in degrees Celsius. When we talk about the temperature or the IGT temperature, there's a couple of temperature probes mounted on that wand there. They're about ½ an inch apart from each other, and we're pretty confident that each is reading correctly. So what you're really getting a sense of is how much the temperature varies over very small scales coming out of these vents, and the challenge of making sure that the wand is in exactly the right area. The best analogy to how Hercules is placed at present is it's a bit like sitting by a campfire on one of those evenings when the wind seems to blow into your face all the time. And so that's why we're getting this very disrupted visual impression from the shimmering water flow as it mixes with the seawater.
At 45 degrees.
Earlier today we measured the temperature at the very base of that vent, about just a few centimeters below where the wand is currently positioned, and that was 280 degrees Celsius. I think at the end of the day today this blue wand is going to be perhaps retired with a Service with Valor award, given the abuse it's taken today.
It's no spring chicken.
One sympathizes. Somebody once described me as not being the sharpest tool in the toolbox, but I counted that I was one of the more durable ones.
I like that.
Always have a comeback.
Sharpest tool isn't always the best tool, John.
You're looking at him right now.
.41 degrees.
I think if I wanted to be a tool,
54.
I'd want to be a multi-tool.
Mm-hmm.
You know?
48 degrees. 49. 50. 57. 55. .52 degrees.
So video, what's the zoom on Argus at the moment?
We are zoomed in a bit, about halfway maybe.
Okay.
Yeah, it just looks so clear, and Hercules is in a cool position right now.
Yeah, it's an incredibly sharp view today.
Yeah, I think they turned off some of the lights from Argus, so
Yeah, I only have one of our big lights on right now.
Okay.
yeah, so the Herc glow,
Has higher contrast.
yeah,
Yeah.
just more glowy.
65
Technical
degrees. .62 degrees.
Oh,
It's a floating spider.
You missed a classic of wildlife TV programming last night, Eric, on the blue water. Sarah gave a wildlife tour of the ROV.
Oh yeah.
Yeah,
Only the front row is here. We
I
had
know.
some blue water to narrate. We're exploring the critters that attach themselves to Hercules during the dive.
Uh-huh.
Met some limpets and some sea
Wait,
spider
I was
crabs.
here for that. I was here almost all day yesterday. It was a very riveting introduction.
I'm glad you thought so.
.57 degrees. Stopping sample.
The low on the IGT was 4 and a high of 30.
End flow counts was 18672.
18672, got it.
For a total volume of 18.2 at 2.3 liters per minute.
.2 and 2.3 liters per minute, got it.
Just let's get a background sample, so something out of the flow.
Out of flow, roger.
Data, what was the end time?
And you want it up high or
1630.
Yeah, high and to
Yes.
the right.
high and to the right, roger. Somewhere over here. Video, you want to come a little wide, please?
All right.
There you go.
Let's go a little wider.
Oh,
I meant on the probe, sorry.
the probe,
Oh.
yeah. Somewhere over here, somewhere.
Yeah, that looks good.
All right, I'm frozen here.
Sarah, what do we got for temperature? Sorry, Michelle?
2.67.
Just want to make sure that I'm plenty far. I should be. But
What do you, sorry?
oh, on the bubble.
Oh, on the bubble.
Just want to look at the tip.
You want to look at the tip and bubble?
Yeah. I know I'm pretty far, but
Yeah.
when I start to make my moves and stuff, make sure I'm clear.
I'm not sure what you're asking.
Ah, never mind. Yeah, later.
Okay.
Starting sample now.
Roger.
1633.30.
So for those of you following on Nautilus Live, this particular patch of the Seacliff hydrothermal vents is a place that we visited a couple of times over the last sequence of dives. Those orange, what look like safety cones in the background are microcolonizer experiments designed to see which bacteria and archaea living in these vicinity of these hydrothermal vents, to see which kind of substrates or materials they like to grow on. We'll be taking a couple of those back to the surface at the end of the dive today. We also label each site quite carefully, so that's what that floating sign with the letter A on just out of the field of view at the moment is doing. At the moment we're taking what I believe is our final fluid sample at this particular location, just one that hopefully represents background seawater. just to address one question we get quite frequently on Nautilus Live about the risks posed to the ROVs by operating in the vicinity of these hot water vents. And for the very hottest ones, if we actually put the ROV right down on top of one, that could well cause significant problems. But it's one thing that the ROV pilots develop with experience visiting, not particularly this site in particular, but others around the world. They develop very good situational awareness for the risks posed at these sites. They're very careful where they put the ROVs down. You're also helped a lot by the fact that at the moment you can appreciate there are very, well, when I say steep temperature gradients, that means the temperature varies by significant amounts over very small spatial locations. So you can see the vent fluid coming out there. At its base, that's about 280 degrees Celsius. If you put the temperature probe about 2 centimeters off to the side, it will measure a temperature more like about 10 or 20 degrees Celsius. Where the blue wand is now, we're measuring a temperature pretty much of ambient seawater, just over 2 degrees Celsius. So the temperature effects of these vents are very highly localized. And that works to our advantage when placing the ROVs.
It's a good explanation, John.
Thank you.
What have the temperatures been on the super wand? The temps on the super wand? Did it take a while to go down?
Not particularly. I think the cracks might have exposed more of the thermocouple. Or so I like to think.
Prevco seems to have, it's up to 1.1 meg on the ground fault, which is improved.
Huh.
So
Interesting.
it's probably just a connector or something like that.
My temperature spiked to 9. 11.
I think we're getting wafting from some of the other vent flows.
Yeah.
That's okay though.
Do you want it up higher or?
No, just leave it there. We'll take some higher samples later.
Roger.
Thank you.
To put it into perspective, Eric, on my desk at home I have a piece of cable that's kind of similar to the tether that runs from Argus to Hercules that was part of Ocean Network Canada's Neptune Observatory. And once it was in position, a new vent opened up underneath it, and it now looks like a very thick piece of asparagus where it parted and melted in somewhere less than a couple of seconds.
Yeah, can have pretty hot flows down here.
Yeah.
As long as I get some data from it.
Asparagus.
Yeah, it's great showing these videos when I give school talks, but there's no substitute for actually bringing in props that have actually been down there.
Have you colored on one of those cups things?
Oh yeah, I've got many of those.
Yeah.
Yep.
Why don't you explain what the cups thing is, Sarah?
Oh, just before you do that, I just wanted to say I saw your Nautilus cup.
Oh, thank you.
It came out very nicely.
Yeah, I'm happy with it.
Yeah.
It's amazing the detail that's preserved
Yep.
when it shrinks.
Sorry, go on.
Well, I was just going to say that there are styrofoam cups that we have that we've been exercising our creativity on.
tapping into our artistic sides and drawing on them with Sharpies, and then we wrap them up in mesh bags very securely, tie them down on top of Argus in the bag very securely, and then they're brought down with Argus as it descends, and the pressure on the styrofoam cups makes them shrink. And so then when they come back up, they are a fraction of the size they were when they went back down. And all the little drawings that we have on them are amazingly well preserved in detail and vivid color. Not that that would fade or anything. It just, they look really good, and they're tiny, which is just kind of cool.
Well, the neat thing is, a lot of people think they'd be squashed flat, but because the water pressure is essentially coming from all directions, it's really like a shrink ray. They shrink down.
It is like a shrink ray. It's crazy. We just have all these little tiny styrofoam cups now.
Yep.
I have no idea what I'm gonna do with them.
What is
but
that creature?
Look at them.
Is that a creature?
I can't hear you, Michelle. What?
The black orb.
Oh, in Argus?
Oh, I don't.
Yeah.
I can't see
jellyfish.
5 seconds left.
Oh.
Roger.
Anyway,
And
it's been
sample.
fun.
But yeah, just to answer your point, we sometimes give them to schools. We'll have schools colour them for us, and we'll take them down and then return to the school and give the kids each back their cup.
Yeah.
That's pretty effective.
To have something this has been down, 2,800 meters or something. It's just kind of cool.
Yep.
Data.
If Cubs could
Yeah,
talk.
go ahead.
End flow counts 26808.
26808. Got it.
And total volume is 23.24 liters.
Got it. 23.24.
At 2.9 liters per minute.
Got it.
IGT had a high of 11 and a low of 1.
All right, let's move that wand on top of the flow, but towards the top of your screen.
Top of, so basically move it up from where it is now.
Up and into the flow.
Up and to the left.
So like kind of like where that monkey ball is to the left.
Roger.
Call monkey ball, or is it monkey
Monkey
claw?
fist. Monkey fist.
Yes.
Yeah.
I'm calling monkey balls.
I think we'll stick
Seems
with fist.
seems a little strange. That one.
Ooh, hey. Hey.
How about, let's make sure. Yeah, I got plenty of space. So there's your flow there. Do you want it a little bit, where do you want this one?
Let's hold it there for a sec, see what we get.
Okay. Is there a temperature range? It's going to be more seawater.
Yeah, I want something that has a little more dilute source.
Roger. Well, look at you.
Getting in the picture.
Wants to come back.
Yeah.
Take me back.
It's too cold down here. Why?
I miss my other letters.
There's another marker just behind her.
Yeah, there's E. or
So
something, I
close,
think.
yet so far.
It's like you parallel parked between them. Can we move to the left an inch?
Left an inch, aye. And you want it a little bit more forward?
As long as it's in a flow. I can't really tell.
Do you want me to bubble it?
Yeah,
Sure.
let's bubble it.
Yeah, it's a little past it, kind of, right? How about this? Let's move it down 3 inches.
Down. 3. rotate it a little bit too.
A little warmer.
IGT is at 15.
Something around here, Eric, or a little bit
Yeah.
higher?
Let's take this. You can lock it up.
Locked up. Looks like you got a good angle there on your tube still.
Starting sample now.
Roger.
1645.
Oh, a fish checking out Hercules.
I'm good, thanks.
It's a big one. Look how long it is.
Sorry, take a look at my deep sea guide here. It looks like they're cusk eels.
I actually scrubbed that. I didn't have the port open.
Okay, so we're gonna restart it?
Yeah.
Okay. And to confirm, we're on port 5 now, right?
Yep.
You're well stocked. Oh, nice.
All right, starting sample 1647.
Got it.
Need help.
So just for those of you on Nautilus Live, let me kind of take a step back from the precise site we're exploring now and give you the sense of where we are in the world and what we're hoping to achieve. So Hercules is currently sampling vent fluid from a hydrothermal vent system that's part of the Seacliff hydrothermal vents. It's operating 2,700 meters under the ocean at the seafloor. The Seacliff hydrothermal vents are just one of a number of active geological features that are part of the Gorda Ridge tectonic plate boundary, where the Pacific and the Gorda plates meet. All of the voices you can hear are coming from the control van of the Hercules and from the Inner Space Center in Rhode Island. The Nautilus is currently stationed above Gorda Ridge, 180 kilometers off the west coast of North America. Just if you want to find us on the map, we're actually on the bottom right panel of the quad feed, or if you feel like going to an atlas and doing it old school, just find where California meets Oregon and trace your line just about 180 kilometers off the coast from there, and that's where we're operating. I guess you could also check us out on marinetraffic.com, search for the Nautilus and you'll find our transponder information. This is our 5th dive at the Seacliff hydrothermal vents, and we've been visiting a number of the vents to make geochemical measurements of the dissolved minerals and gases, microbial measurements of the microbial communities, bacteria and archaea, that support the base of the food chain in these environments. Just a great question that's coming on Nautilus Live. These water samples are returned to the surface, but normally these ones that we're taking with the Super, they're not returned under the same pressure at which they were sampled at depth. So the pressure down here is approximately 270 atmospheres, or 270 times the surface pressure. And so as these super samples are returned, they basically change pressure to as they ascend, and they'll be at normal pressure once they get to the surface. the measurements we made earlier today, the isobaric gas-tight samplers, they do maintain the water at the same pressure as depth, and when we vent them, that's not a particularly dangerous task, but we do it kind of carefully, because as you release the pressure on the water, the dissolved gases come out of solution. So we try to do that in a closed container so that we actually keep those dissolved gases, and we make measurements on them actually using an onboard laboratory. A gas chromatograph gives us the different gas compositions that we've measured at depth.
Oops.
So Nicole, SCF is just going off comms for a little bit because I've got an interaction to go to, and somebody else will be joining us shortly.
Copy that.
All right, thank you.
How high would you guys, excuse me, say that probe is from the orifice?
Sorry?
How high would you say that probe is from this?
Canary on there, Eric.
How high we think it's from the orifice?
Yeah.
So interesting estimation since the scaling lasers are a little far back. Let's see when.
The lasers are 10 centimeters, you said?
Yeah, lasers are 10 centimeters, but they're probably set back another, like a meter to the other rock or so. I would say it's about maybe 40 centimeters up, maybe 50.
Okay.
Are you drifting away again?
Yeah, we're kind of drifting
Yeah.
around.
Maybe we can call in a ship move for like 180. Be a little closer, do you want?
Yeah, I think we're right. I think we're quite to the point of pulling on yet. We just come wide on Argus for a sec.
Yeah.
I think
Like a
might do a
5.
little move.
Yeah, like a 5 meter 180.
Sure.
It gets you just a little bit closer, so I think you keep on drifting back.
Yep. I think
Five.
you just, yeah,
Oh, sorry, 5 meters at 180.
sure. I adjusted his heading a little bit, maybe that, but usually they swing around the stern, so it doesn't usually impact our position. But
Bridge nav. Yeah,
And the
5
sample.
meter step at bearing 180.
Eric, what was that?
And the sample.
Roger.
Flow counts, or end flow counts 35152.
Roger.
High was 15.88 and low of 2.6 on the IGT.
Final volume is 23.83.
Go ahead.
And 3 liters per minute.
Got it.
Just for the next one, we're gonna move it down for like 5 inches.
5 inches further into the flow.
Mm-hmm.
Roger. Am I clear to move down now?
Mm-hmm.
Roger. Coming down. 5 inches. About there? A little more.
A little more.
Roger. How about here?
Let's see. Yeah,
IGT's
that's
at 8.
pretty good. I'm getting about like 10, 11, 12 degrees.
Okay. I'm frozen here.
we can push back in on Argus if you want.
Okay. Roger.
The shadowing's nice, isn't it?
Starting sample.
Roger.
We're not collecting any more of the microcolonizers today, are we? We are? After this one?
Yeah, I think we're getting 2 of them.
So John's doing an interaction right now, and I was just looking over on the, comment feed. Someone was wondering what the orange cones are made from, and why wouldn't they be melting or affected by the temperature?
I think those are made from PVC pipe
Yeah.
and funnel, and some lead weights on the bottom to hold them down. And they're not really in a point source of heat flow. So it's a little warmer, but not to the temperatures that we melted the intake wand at.
Things looking a little worse for wear.
Yeah. But hey, it's what it's designed to do, I guess.
Yeah.
At least I'm getting data from it. All right, end sample.
Roger.
End flow counts 44186.
High IGT was 26, low was 1.96.
End volume 25.8 liters. And 3.2 liters per minute.
Got it.
Jess, let's cover half the distance from here to the orifice, down.
Okay. I'm just gonna take bubble cam from you for a moment.
Mm-hmm.
Just make sure we're lined up nicely. All right, halfway down. How does that look for you, Eric?
I'm getting 6 degrees, 8 degrees.
Go
Looks
away
a
from
little
us a bit.
away.
Yep.
Yeah.
There you go.
Would it be helpful to zoom in a bit?
Well, let's see how this one reads. It looks more square up on bubble cam.
Oh, right, okay.
And we'll just wait for the current to kind of push it towards us again. What are you reading out now, Eric?
36 degrees.
Okay.
That seems to be within the flow.
IGT's in the 20s.
Are we locked up?
I'm locked, yeah.
All right.
I think the flow will come back towards us too.
Yeah, it's
Second.
been whiffing in and out of the tip there. Starting sample now.
Roger.